So we are going to solve this trig equation just like we would solve a normal quadratic equation. So for a normal quadratic equation, I'm pretty sure you've heard your Algebra 1 teacher say it must equal 0. It must equal 0. Well, that's the exact same thing here. So right now it's equaling 5, and we need it to equal 0. So 5 needs to move over to the left side. So truthfully, if I move 5 over, I would have 2 sine squared of theta minus 9 sine of theta, and then I would have minus 5 is equal to 0. Now, from there, again, it's just like a quadratic equation. And I'm actually going to write a quadratic equation that's a little bit similar to this. That way we can reference this. So kind of go through and replace where you see sine of theta with x. So truthfully, if I had to write a quadratic equation, I would do 2x squared minus 9x minus 5 is equal to 0. Okay, that's how it would look if I had to write a quadratic equation. Now, just like you would normally factor a quadratic equation, we're going to factor this. So this would factor into, and you would draw your two groups just like normal. And however you factor this, for me, I know that this is going to be 2x, and then I would have plus 1. Then I would have x minus 5. So that's how that particular quadratic equation would look if you went through and you factored it. Now, remember in Algebra 1, once you factored the quadratic equation, in order to solve, you would take each factor. So you would take like 2x plus 1, you would set it equal to 0 and solve. Same thing here, x minus 5, you would take it, set it equal to 0 and solve. So now let's go back to our actual trig equation. And I'm going to highlight this equation right here. Okay, and we are going to now factor it. So it's basically going to look just like this quadratic equation that we have factored, but every time we see x, we're just replacing it with sine of theta. So if we factor this, you would have here 2 sine of theta plus 1, and then you would also have sine of theta minus 5. That would equal 0. And you can check it just like you normally would check by foiling. So if you foiled this, you would have 2 sine of theta times sine of theta, and that would be 2 sine squared of theta, which is what you need. You would have 2 sine of theta times negative 5. Okay, that would be negative 10 sine of theta. Here you have 1 times sine of theta, which we know is sine of theta. So that's really going to, if you simplify that, that would be negative 9 sine of theta. And then you have 1 times negative 5, which we know is negative 5, right? So now go through and take each factor. So here's a factor, 2 sine of theta plus 1. And also your second factor, sine of theta minus 5. You're going to set them equal to 0, and you're going to solve, okay? So we have 2 sine of theta plus 1 equal to 0. If you solve this, you would get rid of adding 1 by subtracting 1. So you would have 2 sine of theta is equal to negative 1. You would also get rid of multiplying by 2 by dividing by 2. So you're going to get sine of theta is going to be equal to negative 1/2. Now we move on to the next one. You have sine of theta minus 5. If you solve that, you would have sine of theta minus 5 is equal to 0. To get rid of subtracting 5, you would add 5. So you would have sine of theta is equal to positive 5. Now it's going to be our job to identify theta. Okay, so if you think about your unit circle, you really do need to have your unit circle memorized if you are in trig. If you take sine of what angle, so sine of what angle is going to give you 5? Well, hopefully you would say, I don't really know that. I don't really remember a 5 being there on my unit circle. So that means that we would have no solution for that particular equation. Now, this very first equation, you definitely should know what angle, if you take sine of that particular angle, is going to give you negative 1/2. So 30 degrees in that third quadrant, we know that's going to equate to 210 degrees. Okay, and then if we go to be 330 degrees. Awesome job. So this is going to be our answer.